our revision on the basic vector algebra and vector calculus. Okay, so for this one, what I'm trying to highlight is the addition and subtraction. Okay, I think for vector addition and subtraction is straightforward. It's not that complicated. It's just simply do the addition by using this form, this equation 121. Okay, so if a plus b, vector a, vector a plus or minus vector b, so you can have ax vector ax plus or minus bx. Okay, and then the vector is I, and then plus if we have y, so we're going to have ay. Okay, okay, and then the vector is j. Okay, so if we have k, then to be a z plus minus bz, and then unit vector is in k. To make this is clearer, like let us have vector a ti plus 2j minus 5k, and then vector b is minus 2i plus 4j plus 3k. So you do the addition here. So you add 3 plus minus 2, you get 3 minus 2, you get 1i, and then 2 plus 4, you get 6j, and then plus 1 is minus 5 plus 3. Minus 5 plus 2, so you get minus 2k. Okay, so this is a plus b, then this is a minus 2. Okay. That one is for addition and subtraction. So now we have multiplication, which is when you have two vector, we can use dot product. So we have here dot product. Okay, dot product. Okay, so for dot product, you have vector a dot vector b. So you get a. Okay, a times b. Okay, multiply by cosine theta. Okay, so this is formula. Okay, this is the formula. So when you have this one shows how do we get the value of 0 and 1, 0 and 1. Basically, they are using dot product, and relate with this formula. Okay, so for example, I dot j. Okay, so we have I dot j. This is I j. Okay, okay, I dot j dot k, and then k. This is cross. This one is cross. This is later. So I dot j. So I times I, magnitude I times I. Okay, I times I, and then cosine 90. Okay, cosine 90. So what is cosine 90? Cos 90.
You
0, right? So 1 times
0.
0. So j cross k, j dot k also equal to k dot y. So it is 0. Okay, if the unit vector is multiplied by its own, okay, on its own, so I dot I, j dot j, k dot k. So the answer will be 1. Okay, the answer will be 1 because of cos 0. Okay. So you get 1. So therefore, you're going to get this formula. When you do dot product, okay, my question, is a dot product is a vector or a scalar? Dot product. Vector or scalar. Okay. How many of you say dot product is a vector? Please raise your hand. Have a raise hand button there. How many of you? Let me check how many of you say yes. Oh, you do not know that button. How many of you say that dot product is a scalar? Raise your hand. Only two. Two. 1, 2, 3, 4, 5. Oh. What happened to the rest? Maybe they are contemplating. Okay, so dot product is a scalar, right? So you have a value there. No magnitude, no only a magnitude, no direction. Okay, so dot product. So you multiply. So A dot B is going to be AX times BX. So 3 times minus 2, 2 times 4, minus 5 times 3. So you get minus 6 plus 8 minus 15. So altogether you get minus 7. Okay. So what else I want to highlight here? This one talking about projection of a vector onto another axis. Okay, can explore all that one. All right, now it's a cross product. Okay. If just now we use cosine, this time you have a cross product, okay, of the two vectors A and B. So you have A, vector A cross vector B equal to A times B sine theta. Okay. Okay. So what I'm saying here, N is a unit vector perpendicular to both planes, okay, containing a vector A and B. Okay, we look at this figure. What is meant by normal? We have the plane here, blue in color. The vector A and vector B, they lie on the same plane. Okay, and then the perpendicular to this plane is a normal axis. So vector V equal to vector A cross B. Okay, vector product of two vectors. Okay, all right, and how to find the value of I cross J? Okay, the one that I have shown just now, IJ. Okay, so cross J cross K, K cross I. Okay, so I cross J equal to K because it is perpendicular, which is 90 degrees, sine 90. So you get I cross J, you get K, and then the J cross K, J cross K, you get I, positive I. This is positive K. This is K cross I, you get positive J. So if they are crossed by themselves, you are going to get the value of 0. I cross I, J cross J, K cross K, get 0. Okay. How to get this one? Actually, I would like you to have a revision on Cramer's rule. Okay, Cramer's. Because they are going in Cramer's rule later on in the example, I'm going to show you how can get, how we can use, for example, this is AX, AY, and AZ, BX, BY, and BZ, and then we will show you how we can get this value. Okay, how we can get this value. Okay, from Cramer's rule. Okay, this is an example. We use cross product. Basically, what being doing here, they just substitute all of this value using this equation. Okay, but I expect you to know more, not simply know how to substitute straight away from this formula. You need to know how this value come from, which is by using Cramer's rule. This is we are using a 3 by 3 matrix to include I, J, and K. Okay. This one determine the moment of a force about point. Okay. We're going to learn this later on. Okay. This an application of vector product. Okay, vector product. Going to go through this detail later on in in our kinetic of rigid body. Okay. This is a mixed triple product. Okay. Okay. Projection. This one we're going to go through in detail when we cover the second half of our class or semester. Okay, this one is important. We're going to use basic vector calculus differentiation. Okay, pembezaan differentiation rules. Okay, I had mentioned earlier also in our class how to differentiate addition, how to differentiate dot product, how to differentiate cross product, and how to differentiate vector. Okay, vector and unit vector. Okay, so we're going to have 157. Differentiate A plus B. So we do one by one, right? We differentiate A first, and then we differentiate B. Okay, plus and minus. So this one you get A dot, vector A dot, differentiate with respect to time. Okay, A dot plus and then minus. So plus minus. So you differentiate B with respect to time, you get B dot. Okay, that one is for addition and subtraction. Okay, how about for dot product? I have mentioned just now in our earlier class last week. If A dot B, so we start to differentiate the first one, and this one constant. So you didn't differentiate. And then the second part plus you allow this one to become constant, and then you differentiate the second one. Okay, second part, which is B. So differentiate. So you get here, you differentiate A, you get A dot vector times a constant, which is B, then plus you get constant A, and then you differentiate B, you get B dot. Okay, this is 138. Same thing for cross product. Okay, you start to differentiate the first part, which is A, and then this one constant. Okay, okay, and the second part you make A constant and you differentiate B, so you get A dot cross B plus A cross B dot. Okay, this is 139, right? And the last one for magnitude and unit vector, here you have vector A equal to magnitude times unit vector. Same thing you need to do. You take this one as you differentiate A with respect to time, and then U become constant, and then the second part, which is A, become constant, and then you differentiate U. So that's why you get A dot U plus A, which is the magnitude times U dot and U dot. Okay. So what I'm saying here is A dot is dA dt. Okay, it's close to 0. Okay, if A is constant in magnitude. Okay, so A dot equals 0, therefore U dot will become 0 when the direction of U remains unchanged. Okay. All right. Next one. Omega theorem. I'm going to talk about this when we cover the topic of rigid body. Okay, this one. Okay, the coordinate system also I have explained to you last time. The type of coordinate system that we are using: rectangular, cylindrical, normal and tangential, and spherical. But for this class, I didn't cover this one. But you have learned, I think, in mathematics, about spherical coordinate. Okay. And then I also have mentioned to you, I want you to should be able to differentiate between what is global coordinate system, which is fixed reference frame, and then another one is local, okay, local coordinate system. This one also very important when we cover the topic of rigid body later, then to go through in deep about this. Okay, how to transform from local coordinate to global coordinates, then to transform from global coordinate to local coordinates. Okay. 1.4 also the topic in rigid body. Okay. Same thing for this one. Okay, this is the review part. I think I have done this one. Now we are going, we take another 5-minute break, and then I'm going to continue to cover chapter 11 from Beers and Johnson. Okay, 11:20, 11:25, we come back.
Okay, Doctor. Okay, Professor.